this convergence test to me really captures the essence of why we do limit comparison. So there are a lot of really exotic examples, but this is kind of the run-of-the-mill type of example that happens every day. So when I'm looking at this rational expression, I think to myself, well, when n gets really big, the higher powers of n are going to dominate the numerator and denominator to a very good approximation. And that means this is essentially becoming n squared over n to the fourth, which is just 1 over n squared. So that's what we're going to limit compare to. And the argument is like these terms to a good approximation are becoming very close to the same exact things as the terms in 1 over n squared. 1 over n squared is a convergent series, therefore this should be a convergent series. So let's get into the formalities of it. All right, we take the terms of our series and we divide by the terms of the series we're comparing to. That means multiply by the reciprocal. And if I go ahead and distribute that throughout this rational expression, it would look like n to the fourth minus 5n cubed plus n squared over 4n plus n to the fourth. So when I'm teaching calculus, I normally say it's okay to just keep the highest power of n. I know that's going to dominate the numerator and the denominator. And if I did that here, I would end up with just n to the fourth divided by itself, which is 1. However, I like to illustrate in these videos a slightly more formal approach because I know a lot of teachers require it. If I divide by the highest power of n on the top and the bottom, so n to the fourth, I end up with 1 minus 5 over n plus 1 over n squared, 4 over n cubed plus 1. And then here, maybe we proved it earlier in the semester and maybe we didn't, but we say like 5 over n is unambiguously going to 0. 1 over n squared is unambiguously going to 0 and so on. And all that survives here is a 1 over 1. So same result. All right, because the ratio of these terms settled down to a finite number in the large n limit, we conclude that their convergence behavior is the same. Well, 1 over n squared is a convergent p-series because p is bigger than 1. That's a p equals 2. So there's a nice conclusion. Since the sum as n goes from 1 to infinity of 1 over n squared converges, so does the series that we were investigating by limit comparison.